Hello there. Let's get started with this course by just talking a little bit about matter and sort of what chemistry is. So, in terms of chemistry, it tends to fit right in the middle. We often refer to it as the central science, right between physics and biology. So physics sort of borders chemistry in terms of, thinking about the structure of atoms and some of the physical nature of atoms and molecules that we talk about. And then there's the biology side where chemistry provides the underlying sort of atomic and molecular level explanations for all of life. So I know that's kind of dramatic, but, chemistry is essential to understanding these other disciplines. And throughout this course, we'll try to make it clear how those sort of connect, the disciplines connect and inform us about all sorts of, or how chemistry can inform us about all sorts of other disciplines and other topics. And so it's kind of in the middle. Okay, so just to kind of reiterate that, we'll think a little bit about what chemistry is and what chemists do, and we can first talk about matter. So the study of matter and its transformations is really how we kind of define chemistry. And if we think of matter as everything that has mass and occupies space. So if you think about that, that's really everything. So when we talk about chemistry and when you're learning chemistry, you're focused on understanding matter and what it's made of. And so we'll be learning about atoms and molecules and compounds and all sorts of things to kind of put our ideas together about what is happening on that and then transformation. So we'll be talking about this quite a bit because as you can imagine, matter undergoes transformations, and chemists study this. So we study how you can convert one substance into another substance to create new substances. This is referred to as a chemical reaction or a chemical change, and this is a big part of chemistry. So we'll touch on that quite a bit as time goes on. Chemists also seek answers to fundamental questions about all sorts of things, but a couple ideas here. What makes up materials that comprise our world? So again, just really studying structure. What are things made of? What do we know? We pick up a solid or even a liquid or anything like that. What is it made of? What's going on at that atomic level? And also how this composition or what substances are made of impacts or affects the properties of the substances. So there's that next level. Once you know what something's made of, then you can think about how that composition is impacting how it behaves. So there's sort of a structure-function relationship there. Let's see. Also, how substances change when they interact with each other. So again, chemical reactions idea. I've already touched on this, but that's a big one where we're really thinking through chemical reactions and how things are transformed at that smallest atomic level. And then also chemists are really focused on kind of applying this knowledge to making new materials, to understanding the world better, and really thinking through, in terms of this course, what might be interesting to think about is all the medical applications out there and how chemistry has informed their development and their use. And so this could be a treatment for a disease. This could be a tool that we use in an operating room. Kind of spans all of medicine. That chemistry has had a huge role in really kind of putting all of those ideas together for the medical field. Okay. So let's start off by kind of coming full circle back to this idea of matter. What is matter? And when we talk about matter at the very top level, we want to categorize it into a few different ways. And the first way is to think about states of matter, the 3 states of matter. And so as you can see from this image here, we've got the solid state, the liquid state, and the gaseous state. So this is just one way to kind of separate matter into 3 categories. And so let's think about what's going on at the solid state. You can see from this image that in this first flask here, we've got a solid. So we might be looking at that in a flask. You can see it with our eye. There's enough there to see. But if we were able to zoom in to that lowest atomic level, what would we see? And so this image here in this first circle is kind of indicating what we might see and what those atoms are doing. And notice that they're packed together and they're very organized. I'll show you another picture of that in just a minute. But then when we think about the liquid and how it differs from a solid, notice that the particles at the lowest level here are a little bit further apart. Possibly, maybe you can't see that real well in this particular image, but they're further apart. They're moving around one another. They're more fluidly moving, and so it's slightly different than that solid state structure, and not as organized. So tend to be pretty disorganized. And then the gaseous state here. So the gaseous state is very different. The particles are very far apart from one another. They're flying around. There's a lot of movement and kinetic energy involved, and their impact colliding with one another and doing all sorts of things. But the main thing to focus on right now is that the particles are far apart from one another. Let's look at an animation to kind of see this a little better, and I'll probably talk through this a little bit. Okay, so here's first one we can see here in the gaseous state. Well, we have all three, gas, liquid, and solid, but let's zoom into that gaseous state. Now you can get a better sense of what's going on in the gaseous state of matter. The particles are moving around. They are colliding with the container. They're colliding with each other, but the key is that they're far apart from one another when you compare these to liquids and solids. So they will fill whatever container they're in. That could be the room, could be the container. Here's the liquid state. This gives a better view of the liquid state. They are definitely disorganized. They're moving around, but they're touching each other. They're attracted to one another, but they're much more fluid, and so you can pour liquid out, as you know. But think about the atomic level. And then the solid state. The atoms there are very close together, very organized, and that's what makes kind of that structure at that atomic level different than a liquid or a gas. Okay, so I hope that is it's kind of our first way of separating out a solid from a liquid, from a gas, or our first way of sort of classifying matter. So changes in matter. First of all, we'll talk about what's called a chemical change. This is a process that results in the formation of a new substance. So again, like a chemical reaction, you start with one substance on the molecular level, and then there's a change. Bonds are broken, and we'll talk about what bonds are later. But the substance is being altered into a new substance when a chemical change takes place. And then we can contrast that with what we call a physical change. And this is a process that results in no new substances, so it's not the same as a chemical change. But there might be a change of state or some other physical change. The most common physical change that we talk about is a change of state. So you might have a solid that goes to the liquid state, but the component at the molecular level or the atomic level stayed the same, so it was not a chemical change. So we can look at an example here is an example of physical change where we have solid water. So we have basically ice over here, right? We have solid water, and it is undergoing a melting process or a state change to go to liquid water. And so the only difference that occurred here is we had a state change, and at that molecular level you could see sort of the change in how it looks. The particles will be more fluid, they'd be moving around one another and more disorganized. We can also go back the other way. So imagine a state change from a liquid to a solid. So that can also occur, and we have obviously, so we can have freezing, and we have the liquid water. The water molecules are coming closer together, becoming more organized, and then they enter that solid state. And these are both examples of physical changes. So those are state changes. But notice that the water molecule itself did not change. It's water in the liquid state, and it's water in the solid state. So water has the chemical formula H2O. That's the same in the liquid state as it is in the solid state. And here we have an example of a chemical change. So in the chemical change, in this case, what we have is, this is when we apply electric current and it's decomposing water. So what we have is water in these tubes, and it's decomposing the water. So we're getting H2O is going to H2, or hydrogen gas, plus O2. So there is a chemical change. In other words, water, which was H2O, is changing into H2 and O2. Now that's not that's when you have to apply electric current to make that happen. That doesn't just happen in a phase change like we saw over here. So two very different things. One a chemical change and one a physical change. Okay, what do you think? Let's try one. Which of the following is not a chemical change? I'm going to give you a moment to think about that. Okay, hopefully you had a moment to think. And the question again, which of the following is not, so that's kind of, got to keep that in mind, a chemical change. So a match burns in air. I think that would be a chemical change. I'll just write CC for chemical change. A match burning in air is a kind of a combustion reaction where the substances on the tip of the match are actually reacting with oxygen in the air to produce a reaction. Ice melts in air. So here we have, if you remember, a sort of a change of state. Would that be physical or chemical? That's right. That would be a physical change. And so I think that might meet our criteria of not a chemical change. So let's keep B in mind. An aluminum door whitens in air. So we talked about whitens or color changes as being an evidence of a chemical change. And so would likely be a chemical change. And then all of these, I don't think so because B was not. So not this one, not this one. And none of these, I think we found one that it is. So let's cross all those out. And then I think we would say B would be our answer. Okay, I hope you got that one. Here's another one to think about. So in this case, what do you notice? If we start at the first bubble A here, take a look at what's there. We've got some substance that has two red balls and a blue ball, and they're all the same here. And I'm curious what you think. If we go in this direction towards C, notice what do you think's happening there? Does that look to you like a physical change or a chemical change? I'm going to give you a moment to think. Okay, hopefully you noticed that nothing has changed in the composition of each one of these molecules. They're still all two red and one blue, 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 two red and one blue. There's nothing that has changed in terms of the what that compound looks like. So I think we'd have to call this a physical change. And what about this direction? See if you can notice anything that happened going in this direction. Yeah, this would be a chemical change. We'll call this a chemical change because notice that what we have over here are some of the red ones are on their own, and then we have red and blue together. So there's different substances at that tiniest level, at the molecular level, and this looks like this underwent a chemical change or a chemical reaction where it broke apart and new substances were formed. So that's an example of a chemical change. Okay, well, that's it for this video. I will sign off for now and see you in a bit. Take care.